Let us begin with the derivation, what is called as most probable velocity. To obtain the expression for most probable velocity, what we'll do, already we have studied a good level of mathematics. We know very well, like maxima and minima functions. If I want to derive the most probable velocity, that is velocity corresponding to the distribution law, where we have the peak value according to graphical representation. To obtain the expression, we differentiate the expression of Maxwell's law of distribution of velocity with respect to c. To obtain the most probable velocity, let us differentiate the expression of Maxwell's velocity distribution law with respect to c and equate it to 0. That means we have this dn upon n, or dn is equal to the most probable velocity, corresponding to maximum probability, probability. We differentiate Maxwell's velocity distribution law with respect to velocity and equate it to 0. Let me write here dn. This is d by dc of dn, and equate it to 0 at c is equal to cmpv. We do such differentiation while finding maxima and minima of a given function. Please remember that. I'll write Maxwell's velocity distribution law, Maxwell's expression say that is dn is equal to 4 pi n aq e to the power minus bc square c square dc. Differentiate this, that is d by dc 4 pi n aq e to the power minus bc square c square dc, equated to 0. You can write at c, the velocity c is equal to cmpv, most probable velocity. Let me differentiate this, that is 4 pi n aq. This is constant, 4 pi n aq, a is constant, b is constant, but b is along with c. So this is, I'll write e to the power minus bc square as it is. I will differentiate this, that is c square is 2c, plus I will differentiate, that is 4 pi n aq, c square I will write here, differentiating this e to the power minus bc square minus 2bc, equated to 0. Fine. At c is equal to cmpv. Let us take common term from this, both the terms, that is 4 pi n say aq. This is also common. I have written here, that is 4 pi n aq e to the power the term is missing here. Let me write once again. 4 pi n a cube e to the power minus b c square into 2c plus 4 pi n a cube e to the power minus bc square c square, I'll write here minus into 2bc, which is equal to 0. Let me simplify this further. 4 pi n a cube e to the power minus bc square, and take a common. What is remaining here is 2c minus, say, 2bc, that is c square, one more c cube, which is equal to 0. So when I equate this term with a 0, what is remaining with us is, say, 2c, I'll write it here, into bracket 2c minus 2bc cube is equal to 0. So I'll take 2c common, 2c into bracket 1 minus 2b c cube. It is 2 is not here, bc square, which is equal to 0. So we have this 1 minus bc square, where c is at cmpv square, which is equal to 0, or bc square mpv is equal to 1. Let us substitute the value of b. I'll write it here. I'll rub this. Okay. B is m upon 2 kt, m upon 2 k, the Boltzmann constant, t, b here, c, say mpv, that is most probable velocity square, is equal to 1. We got thus. So let me write this c square mpv is equal to 2 kt, k the Boltzmann constant, T the absolute temperature, upon m. I want only CMPV. CMPV most probable velocity, that is taking the square root, we have, say, 2 kt upon m. And this is the expression. Still we can simplify it. We know this Boltzmann constant K is R, the gas constant, by N, the Avogadro number. Small m, this mass of the gas, is its molecular weight divided by Avogadro number. Using this, I'll write CMPV is equal to, say, into bracket square root under square root 2 R, that is K is equal to R by N, T upon M. M is equal to capital M upon N. That's under square root. If you simplify this further, this will be, say, under square root 2RT upon N into N by M. Whole thing is under square root. This will be equal to, say, CMPV is equal to under square root 2R, gas constant, absolute temperature, divided by capital M, when m is the molecular weight, n is the Avogadro number, m is the molecular weight, and the same thing I have given in my notes. Please go through it. Let us go for another term or another velocity expression, that is mean or average velocity. Hope you understood this. Let me pass on to mean or average velocity. Mean or it is average velocity on the basis of Maxwell's law of velocity of distribution or on the basis of kinetic theory of gases. So this mean or average velocity, I will write CAV or C bar. Many times they write it as C bar or C mean. Fine. To obtain the expression for this, each expression, if they ask, it carries 5 marks. One thing, obtain the expression for mean or average velocity on the basis of kinetic theory of gases or on the basis of say Maxwell's velocity distribution law. It carries 5 marks. If not, these 3 expressions, most probable velocity, mean velocity or Rms velocity expression, help us in solving the various number of problems. Let dn, its derivation, dn are the number of molecules, the fraction dn by n is the probability, and this dn by n, the probability is a function of c. I will write thus. This dn number of molecules having the velocity in the range c and c plus dc. We know this, c and c plus dc. So if I find this dn number of molecules which are having the velocity c and c plus dc, and if I have a product that is dn, which is a function of velocity c at a steady state, and this is its velocity. If find the product of this, and if you find the sum of such products for all the possible molecules, and if we divide by total number of molecules, we get what is called as mean or average velocity. Normally this is done, say like this, say it is ranging from 0 to say n, okay, dn, c, this is summation divided by n. This gives the average velocity, because the distribution of gas molecule is a continuous process. We can replace this summation by integration. Therefore, I will write here that so C bar is equal to integration 0 to infinity. Normally we assume the gas molecules, they move with different velocities ranging from 0 to infinity, and therefore we have taken the limit of integration 0 to infinity, because this product, the say dn of C into C is taken or the range within the limit 0, C is equal to 0 to C is equal to infinity, and then it is divided by total number of molecules, that is you can say 0 to infinity this time. Same thing is replaced here in the form of integration. C average or C bar 0 to integral 0 to infinity dn, which is function of C upon n into C. This is not multiplication, don't get confused with. Here we have tried to represent dn as a function of velocity C. Now I'll write this is equal to integral 0 to infinity. Once we understood this, dn C upon n or C dn upon n. So now I will substitute for dn. I will take 1 or n, integral 0 to infinity, this 1 or n as it is, 1 or n integral 0 to infinity 4 pi n a cube e to the power minus b c square into c, this dc. We have this n and n gets cancelled, so here C bar is equal to integral, I'll take the term first common, that is 4 pi a cube out of integral sign 0 to infinity. What is remaining here? E to the power minus bc square c cube dc. Now this is constant. This integral provides a value, that is this integral is a standard integral using, so I'll write using standard integral. We are using some standard integrals here in all the books or in literature. They use the list of standard integrals in this topic called as kinetic theory of gases. Using standard integral, fine, say integral 0 to infinity e to the power minus bc square c cube dc, and its value of this integration is, after the integration, it is 1 or 2 b square. Let me write this C bar is equal to 4 pi a cube into the value of the integral, that is 1 or 2 b square. We'll simplify this further, that is equal to 4 pi. I'll substitute the value of a, that is m upon 2 pi k t. This is a cube, it is under square root, so 3 by 2 into 1 divided by 2 b square, that is m square upon, it is m square, say 4 k square, say t square. If you simplify this will be equal to, that is C bar or C average will be equal to under square root 8 k t upon small m pi. Or if you are writing using this, C bar is equal to 2 upon under square root pi b in terms of the constants. So this is the expression, that is C average is equal to under square root 8 k t upon m pi. You can write this in terms of, say, k is equal to r n, that is. Hope you got this, that is mean or average velocity. Let's go for another term, what is called as root mean square velocity. I'll write this root mean square velocity. So let me write root mean square velocity. Or this is called as RMS velocity. You can write small or big, that makes no issue here. RMS velocity. Or it is denoted CRMS. The subscript is RMS, either small or big, preferably small RMS. Look at this root mean square velocity. Square of the velocity. Which velocity? Average velocity. Square of, take the square of average velocity and then, or mean velocity, take the square of mean velocity and find its root. You will get root mean square velocity, and it is defined through this equation. RMS velocity is defined through equation C square, C bar square. C bar is the average square of that is equal to 1 divided by n, total number. CdN we have written by definition, the integral 0 to infinity. CdN divided by n is the average velocity, a definition. C square, C bar square, that is, C square dn. Let's substitute for dn here. That is equal to, say, 1 divided by n. Integral 0 to infinity. Substitute for dn 4 pi n. Instead of a cube, I'll write its value b by pi under square root b cube upon pi cube. C square, one more, that is c raised to 4, e raised to minus bc square dc. Hope you got this. Let me write one more step here. 4 pi, this n gets cancelled. Integral 0 to infinity. So under square root, I'll write this b cube upon pi cube, c raised to 4, e to the power minus bc square dc. I'll take this term also out of the integration sign, that is, say here 4 pi under square root b cube upon pi cube, integral 0 to infinity, say c to the power 4 e raised to bc square, say dc. Now we are using one more value of the standard integral. Say I'll write WKT. We know that WKT, that is integral 0 to infinity c to the power 4 e to the power minus bc square dc, and its value is known in the form of standard integral 3 by 8 into under square root pi by b raised to 5. Keep this in mind. Let us substitute the value of this integral in this will get C square. C bar square is equal to 4 pi under square root d cube upon pi cube into one more, that is 3 by 8 into say pi by b raised to 5. We'll simplify this. After simplification, you do little work, simplify it and confirm it yourself. If not, please do ask about this. This is C bar square. I want, I'll have this few steps, so it will be convenient for me to write on the board. Say here, that is, we got this C bar, that is square of the average velocity, and the square of the average velocity is 3 by 2b. Oh, yeah, 3 by 2b. Now, I want to take, say, square root of this C bar square, and that is equal to CRMS. This is for you to understand. So you have to take the square root on the other side also, that is 3 by 2b. Substitute the value of b, you will get the square root of 3kt, it is under square root upon m. You can write this relation in terms of CRMS. CRMS is equal to, in terms of RT, 3 RT T upon capital M, the molecular weight. Sometimes they give this gas constant, they give the temperature of the gas, and they give the molecular weight of the gas, or they mention the gas type of a gas, where we can calculate root mean square velocity at all. We have obtained these three expressions. Let us summarize them and see, is there any ratio, is there any relation between them. I'll write on the board, say mean velocity, expression mean velocity, or say average velocity, C bar or C average, and the expression is, say, it is given by this 2 upon square root of pi b. And if you substitute the value of m and if you simplify, you will get this, that is under square root 8kt upon pi m, pi small m. Check this, that is average. Yes. Well, we have this relation, A is equal to B upon pi, right, and B is equal to the constants m upon 2kt, m upon 2kt. So RMS velocity, the expression for root mean square velocity, root mean square velocity, that is, say, C bar square root of 8, that is CRMS. Please remember this. That is CRMS. Just now we have derived. We got this is 3 kt upon m, that is equal to, say it is under square 3 kt upon small m, or it is equal to 3 rt upon capital M. Check this also. We have what is called as CMPV, the most important velocity, most probable velocity, and that is equal to under square 1 by v, that is equal to under square 2 kt upon small m, or it is given by this, that is 2RT upon M. If you play with these formulas, it will be easy to remember, right? This topic is so important even in chemistry, even in physics. If you have any entrance examination, they do ask this, especially in PG examination or sometimes high level competitive examination. Let me write the ratio. Say most probable velocity CMPV is to C bar, the average velocity is to CRMS. I have taken one ratio, you can change, and that is same as, say 1 is to 2 upon square root of pi is to, say square root of 3 by 2. This is, you can simplify this, this is equal to or same as, say 1 is to 1.129 or 8 is to 1.225, 3 by 2. So I have given this, we will use them. My suggestion here, students, don't be under bad impression that you will not have the examination. Take it granted that you will have the examination. You are preparing, that means you are studying, you are at your home. Now you have ample of time with you. Don't waste your time. Many of us, we are bombarding the so many videos, and we are asked, you have been asked to say join for the online class. Thing is, this is better what I feel, because if you do not understand any concept, you can repeatedly watch, and there is no time. You can watch when you are in the bed, whenever, or you are in the bath. So there is no problem on it. Instead of spending time with watching something else on the mobile, you can watch these videos. I tried to my level best to give maximum to you.